My name is Brian Cronin, and I'm very pleased to welcome you to this tutorial on drafting EQE Paper A based on the European Qualifying Exam 2014 Paper A Electrical Mechanical. This is part 1 of the tutorial Assimilation of Information. Here is a brief introduction to the tutorial. The tutorial is presented in 3 separate parts in 3 YouTube videos. Part 1, which is the present part, is assimilating information. Part 2 is organization and planning. And part 3 is the end product and some comments. I recommend that you follow the tutorial in this sequence. If you are already familiar with the nutcracker and invention and the prior art, you may want to skip this part 1 or zap through it quickly as revision and go straight to part 2. Now I turn to the subject of the tutorial. As mentioned, the tutorial is based on the 2014 EQE Paper A Electrical Mechanical. If you don't already have a copy of the paper, I suggest you download one from the EPO website under the captions Learning and Compendium. The tutorial is in English, but you can do your work on the French or German version if you wish. The subject, the invention covered, is a nutcracker, which is a simple mechanical invention with no electrical component, not even a plug. If you are a chemist, you should be able to handle this subject matter as part of your professional development. Note that from 2017, there will be a single EQE drafting paper on subject matter accessible to everyone. So doing this example will be good practice for chemists planning to take paper A in 2017. Next, we begin with familiarization with the terminology. I'm assuming you are unfamiliar with the subject. As a first step, you need to familiarize yourself with the terminology of the invention. This is not idle browsing. You need the terminology for your future claims. You can initially concentrate on terminology without worrying about how the device works, so you can begin to get to grips with the building blocks for your future claims and achieve a comfort level for later purposeful reading, which we will do. With the mechanical drafting paper A, we have the luxury of drawings, so you can focus your first scan on the drawings and the related parts of the description. So let's now scan through the client's drawings and the corresponding description. Do you have the client's description handy and the drawings? Good. You can focus your first reading on the parts of the description relating to the drawings. This is good. And doing this, you should write the names of all of the elements on the corresponding parts of the drawings. On the slide, I have shown client's figure 3, and we can write on that figure. You should write down on your copy of the figure the names of the different parts, which are: 1 is the upper plate, 2 is the lower plate, 3, 4, and 5 are rods, 13, 14, and 15 at the upper end are ball joints, just as 23, 24, and 25 at the lower end are ball joints. We can, if you turn, I don't have on the slides figures 2, 3, 4, and 5. Figure 2 shows a ball joint. If you take the client's drawings now, figures 3, 4, and 5, you can easily see what is going on. Just by looking at figure 3, you can see that a walnut is placed in the nutcracker between the rods, while the device is standing upright there. Figure 4, which is the next drawing, shows what happens when you turn the upper and lower plates relative to one another. The rods get inclined and squeeze against the walnut, and you can see in figure 5 that when the plates are further turned, the rods are further compress the walnut until it is cracked. And we can see in figure 6 that there is a variation with handles 11 on the top and bottom plates. Good. So the drawings are somewhat self-explanatory, and as we have seen, you can pick up a lot of information just by glancing through the drawings. Let's now turn to client's figure 7, which is shown on the next slide. Figure 7 is the client's second embodiment or second example of a nutcracker, and we can see just by looking at the figure 7 that the ball joints have been replaced by hinges and the upper and lower plates are rectangular instead of being circular. It's still, although the reference signs still have the same meaning, it's good to write them up again on the drawing. So we have upper, 1 is rectangular upper plate, 2 is rectangular lower plate, 3, 4, 5, and 6 are rods, 13, 14, 15, and 16 at the top end are hinges, and 23, 24, 25, and 26 at the bottom end are hinges, the hinge being shown in detail in figure 8 with a hinge pin 10. Now, I have not shown figures 8, 9, and 10 on the slides, but I recommend that you should go to the client's figures 9, 10, and 11 just to see what is happening. In figure 9, we can see that the nut is inserted while the rods are upright. In figure 10, we can see that the rods 3 and 4 are inclined so that the nut gradually gets squeezed. And in figure 11, we can see that when the trapezium, which is formed by the 2 plates and the rods, is inclined even further, the nut is cracked. So that's a glance then at the client's figures. Now we'll have a look at the figures from the prior art documents, starting with document D1, which is now shown on the slide, figure 1 of document D1. We need to write the names of the different parts. So we have 1 is a straight connecting element, 2 is another straight connecting element, 3 is a curved connecting element, 4 is a lower lever, 5 is an upper lever, 6 and 7 are pins. So we can see just by looking at the drawings that the 2 levers are pivoted to the connecting elements by pins. And I invite you to take a look now at the further figures of D1, figure 2, figure 3, and figure 4. If you have that open, you can see from figure 2 that when the upper lever 5 is pivoted open to a completely open position, the walnut can be inserted in the space between the connecting elements. Then the lever 5 is pivoted down in figure 3, and in figure 4 we can see that it's pivoted down even further to crack the walnut. We'll read the document in detail later. Next is prior art document D2 and its drawings. Here we have figure 1 of D2. We need to check the terminology. 1 and 2 are blocks. 3, 4, 5, and 6 are parallel rods. 7, 8, and 10, 11 are rigid strips, and 9 and 12 at the opposite ends are rings. We can see from D2's figures 2, if you would take D2's figures 2, 3, and 4, I don't have them on the slide, but you should have them with your papers. We can see that in figure D2, the plates 1 or 2 are spread apart by pushing the rings 9 and 10 together, so a walnut can be inserted in the space between the plates 1 and 2, or the, what did we call them? The bodies, blocks 1 and 2. We can see in figure 3 that when the pull rings 9 and 12 are pulled apart, the plates 1 and 2 come together until they enclose the walnut and hold it in the nutcracker. And we can see in figure 4 that when the rings 9 and 10 are pulled further apart, the plates, I keep calling them plates, but they were blocks, the blocks 1 and 2 are squeezed even further together until the walnut is cracked. So we can see then that in this embodiment of D2, the 2 blocks are slidable on the 4 parallel rods. Now we need to make a purposeful reading of the documents. The purpose of here are some general comments before we go to do it. Here are some general comments on purposeful reading. The idea of purposeful reading is to concentrate on aspects we need for later processing. We need this to get to grips with embodiments of the invention for further definition. We need to understand operation so you will be able to express operation in a claim. We need to consolidate terminology that we will be able to use for our later claims and detect technical features to be claimed. And very important for the EQE, we need to detect hierarchical statements such as essentially, preferably, and so on, which are going to help us to place the elements in a hierarchy of essentiality or non-essentiality. And while doing this, it would be a good idea if we make some notes on the documents for easy retrieval of the information later. Let's now go through the client's description. Let's brush through the description paragraph by paragraph. On the slide I have put down some notes of points I have extracted and which I thought were worthy of making notes. You should, as we read through the document, you should make your own notes or underlining or highlighting on the description. Be careful, however, not to highlight too much because you can't retrieve anything later. You should keep the client's drawings handy as we read through the description. So let's start with paragraph 1 of the client's description. I am a vegetarian and eat all sorts of nuts. I have several nutcrackers at home. Some of them are better at cracking large nuts such as walnuts, and others are better at cracking small nuts such as hazelnuts. I have invented a nutcracker that can crack nuts of different sizes. So against this paragraph I noted just the last words, the nutcracker can crack nuts of different sizes. Then we jump to the client's paragraph 2, which reads as follows. Figure 1 shows a perspective view of a first example of my nutcracker. It has an upper plate 1 in the form of a disc and a lower plate 2 in the form of a disc. Each plate 1, 2 has a through hole in the middle. The plates 1 and 2 are connected to each other by means of 3 rods, 3, 4 and 5. The diameter of the plate 1 is larger than the diameter of plate 2. The rods 3, 4 and 5 are of equal length. So against this paragraph I just noted plate, disc, through hole, plates of different diameter, rods of equal length. We go to paragraph 3. If you have it ready, you can read it. As I read it out, you can read through it and make your notes on the document. Paragraph 3 says the rods 3, 4 and 5 are attached at their upper ends to the plate 1 by means of 3 ball joints 13, 14 and 15, which we already saw in the drawings. The ball joints 13, 14 and 15 are equally spaced from each other and from the center of the plate. Similarly, the rods 3, 4 and 5 are attached at their lower end to the plate 2 by means of 3 ball joints 23, 24 and 25. The ball joints 23, 24 and 25 are equally spaced from each other and from the center of the plate 2. So against paragraph 3 I simply noted ball joints equally spaced from the center. Then we go to paragraph 4, which refers to figure 2, and it says, by way of example, figure 2 shows the ball joint 25 in a vertical cross section. The ball joint comprises a ball arranged on the end of the rod and a socket 10 arranged in the plate 2 for retaining the ball. The ball joint 25 allows the rod 5 to rotate with respect to the plate in any direction within about 30 degrees from the vertical. Such ball joints are known. So I noted against paragraph ball joints known, rods rotate up to 30 degrees from vertical. You may make your notes on the points which seem to be worthy of making a note for yourself. Paragraph 5 simply refers to the drawing, so there is no technical information. Paragraph 6 reads as follows. Firstly, a walnut is inserted into the nutcracker from above through the through hole in the plate 1. Alternatively, a small walnut can be inserted from the side by pushing it through the gap between 2 rods. Fig 3 shows the walnut held in the space between the plates 1, 2 and the rods 3, 4 and 5, approximately halfway between the plates. So my note, you may note what you think is worthy. My note was walnut inserted via through hole or from the side, walnut held in space between plates and rods, about halfway down. Paragraph 7 of the client's description then says, secondly, holding the plate in one hand and the plate 2 in the other hand, I rotate the plate 1 arrow A relative to the plate 2 arrow B. This causes the rods 3, 4, and 5 to move relative to each other so that the space between the plates 1, 2 and the rods is restricted and the walnut is squeezed by the rods. And that is reference figure 4. Here the information that I noted down was plates rotates cause rods to move relative to one another to restrict space and squeeze walnut. And then we go to paragraph 8, for which you need to look at figure 5. Paragraph 8 says the plates 1 and 2 are further rotated relative to each other and the space between the plates and the rods 3, 4 and 5 is further restricted until the walnut is cracked by the rods. And I have noted further rotation cracks the walnut. Note that these paragraphs are much easier to read and understand if you have already a preliminary understanding just by looking at the drawings themselves. We were up to paragraph 8. Now I go to the next slide, which is paragraph 9. And let's see, what does the client say in paragraph 9? To crack a small nut such as a hazelnut, the plates 1 and 2 must be slightly rotated before the nut is inserted. This restricts the space between the plates 1, 2 and the rods 3, 4 and 5 so that the nut can be held in the space approximately halfway between the plates. So I noted to crack a small hazelnut, rotate plates slightly before insertion. We come then to paragraph 10, which the client says the nutcracker could be improved in many ways. So this is a paragraph talking about improvements, which is going to be quite important for our future claim strategy. What does the client say? For example, in order to prevent a nut from slipping on the rods could be curved or have ridges or protrusions. Alternatively, the rods could be coated with non-slip paint. To prevent a nut from jumping out of the nutcracker while it is being squeezed, 4 or even 5 rods could be used instead of 3. In any case, at least 3 rods are necessary to securely hold the nut. Furthermore, the rods do not have to be of exactly equal length. The upper and lower plates could also have the same size. So these are improvements which are important information, and I've noted down rods curved with ridges, protrusions, non-slip paint, 4 or 5 rods possible, at least 3 rods necessary. Rods can be of unequal length, they can be equal or unequal, and the upper plates can be of different sizes, and as we saw before, or they can be of the same size in this embodiment as a variation. So then that takes us from paragraph 10, we turn over the page and we come to client's paragraph 11, and here the client says, I have noticed that if a nut is particularly hard, my hands slip on the plates 1 and 2 as I rotate them, so that I am unable to crack the nut. To solve this problem, other support elements for supporting the rods, such as cubes, could be used instead of plates. Another idea for overcoming this problem is to change the form of the plates 1, as I will explain below with reference to figure 6. So what I've noted down then is, for paragraph 11, Plates can be other support elements such as cubes, or you can change the form of the plates. And then we go to client's paragraph 12, for which you need to look at his figure 6. The nutcracker of figure 6 differs from that of figure 1 in that the plates 1 and 2 have handles 11 and 12. The handles 11 and 12 form levers which increase the force that can be exerted on a nut. I have not had time to make a prototype of this nutcracker, so I tried to solve the problem in a different way. I screwed the lower plate 2 of the nutcracker shown in figure 1 to a table. In this way, I was able to rotate the upper plate 1 using both hands, which is easier than using only one hand. So against paragraph 12, I noticed figure 6, handles can have handles forming levers can be used, and the lower plate can be fixed to a table. And then we jump to client's paragraph 13. Which says the table I was using was a folding table having legs attached to the tabletop by means of hinges. Unfortunately, the table collapsed as I was cracking a walnut. However, this gave me an idea for a second example of my invention that is shown in perspective in figure 7. So there is a second example in figure 7, and then we'll next go to the client's paragraph 14 describing the figure 7 embodiment. Let's see, what does the client say in paragraph 14? The nutcracker figure 7 has a rectangular upper plate 1 and a rectangular lower plate 2, as we saw just by looking at the drawings. The plate 1 has the same size as the plate 2. Plates 1 and 2 are connected to each other by means of 4 rods, 3, 4, 5 and 6, that are parallel to each other. The rods 3 and 4 are separated by a gap through which a large nut, such as a walnut, can be inserted. The rods 4 and 5 are separated by a smaller gap through which even a small nut, such as a hazelnut, cannot pass. So for paragraph 14, I noted from figure 7, there are rectangular upper and lower plates. There are 4 parallel rods with a large gap through which the walnut passes, and a smaller gap, 4, 5, through which a hazelnut does not pass. And then we turn to paragraph 15, which I have to turn over the page of the client's letter for paragraph 15. And here there is further definition of figure 7, reading as follows. The upper ends of the rods 3, 4, 5 and 6 are attached to the plate 1 by means of 4 hinges 13, 14, 15 and 16. The hinges 13, 14, 15 and 16 are arranged at the corners of the plate. The hinges 13 and 14 constrain the movement of the rods 3 and 4 relative to the plates 1 and 2 to a first plane. The hinges 15 and 16 constrain the movement of the rods 5 and 6 relative to the plates 1 and 2 to a second plane. The lower ends of the rods 3, 4, 5 and 6 are attached to the plate 2 by means of 4 hinges 23, 24, 25 and 26. Because the rods 3, 4, 5 and 6 are of equal length, the rods can rotate through 180 degrees relative to the plates 1, 2. So that's what the client said. It's rather complicated, but we've understood it already from the drawing. And I've noted down 4 hinges at the corners of plates. Hinges constrain movement of rods relative to plates in first and second planes, and rods can rotate through 180 degrees. Then we jump to the client's paragraph 16, which refers to figure 8, which you should have handy. By way of example, figure 8 shows a vertical cross-section of the hinge 23. The hinge 23 comprises a pin, which is fixed to the plate 2. The pin 10 passes through a hole in the lower end of the rod 3. The hinge 23 allows the rod to rotate by up to 180 degrees about the pin 10 in the first plane, and it says such hinges are known. So against paragraph 16, I said hinge comprises pin, hinges known. And I go to paragraph 18. 17 refers to figures 9 to 11, which you should have handy for looking at the operation. But since you've already seen these figures and figured out the operation, the reading is now formality. So in paragraph 18, the client says, firstly, a walnut is inserted into the nutcracker through the gap between the rods 3 and 4. Figure 9 shows a walnut held on the plate 2 between the rods 3, 4, 5 and 6, and it says in brackets, the rods 5 and 6 cannot be seen. So that was paragraph 18, walnut inserted through gap between rods, no apertures. Paragraph 19. Secondly, the plate 1 is moved, figure 10, arrow A, relative to the plate 2. This causes a rotation of the rods 3, 4, 5 and 6 relative to the plates 1 and 2. The rods 3 and 4 move relative to each other. The same applies to the rods 5 and 6. However, the rods 3 and 6 do not move relative to each other. The same applies to the rods 4 and 5. The space between the plates 1 and 2 and the rods 3, 4, 5, 6 is restricted so that the walnut is squeezed by the plate 2 and the rods. Figure 10. So I noted for paragraph 19, plate 1 moved transversely. It didn't actually say transversely, but that's what I understood. Rods rotate relative to plates. Space between rods restricted. Walnut squeezed. And then we turn to paragraph 20, which is figure 11. And we have to turn over the page of the client's letter. Paragraph 20 says, if the plates 1 and 2 are moved further relative to each other, the walnut is cracked by the plate 2 and the rods 3, 4, 5 and 6, figure 11. When cracking a hazelnut, the plates 1 and 2 must be moved even further relative to each other before the hazelnut is cracked. So that was paragraph 20, plates moved further, walnut cracked even further for hazelnut. Paragraph 21. To make the nutcracker more stable when standing on a table, the lower plate 2 can be fixed to a surface, for example, the tabletop. Furthermore, the hinges do not have to be arranged at the corners of the plates. The nutcracker could have more than 4 rods. When I tried to reduce the number of rods below 4, I realized that the nut tended to jump out of the nutcracker before being cracked. I found that at least 3 rods are necessary. For example, in the nutcracker of figure 7, the rods 3 and 6 could be replaced by a single rod. So I noted the lower plate can be fixed to a tabletop, hinges not necessarily at corners, more than 4 rods possible, at least 3 rods necessary. and I go to the client's paragraph 22. In principle, in both examples of my invention, in other words, in all embodiments, the rods could be attached to the plates elsewhere than at their ends. For example, the rods could extend above the upper plate as a decorative feature. In both examples of my invention, instead of connecting the plates to each other by rods, other connecting elements such as tubes could be used. The nutcrackers should be made from a stiff material such as stainless steel. So this paragraph 22 contains a lot of useful information for us, and I have noted down rods attached to plates elsewhere than at ends. Rods can be other connecting elements such as tubes. Nutcrackers should be made of stiff material such as stainless steel. And then we go to paragraph 23, which says, for your information, documents D1 and D2 are annexed to this letter. D1 and D2 describe nutcrackers that are currently available on the market. Like my invention, the nutcracker of D1 uses a lever effect. This effect minimizes the strength a person needs to crack a nut. The nutcracker of D2 can crack nuts of different sizes. However, with the nutcracker of D2, skill is needed to crack nuts without completely crushing them. So I noted for paragraph 23 that D1 and D2 are prior art nutcrackers. D1 and the client's invention use a lever effect to minimize the strength needed, and with the D2 nutcracker, skill is needed to crack nuts without crushing them. And then over the page there is a paragraph 24 dealing with more formal things. You are asked to draft claims and an introduction for a European patent application, assuming the drawings will be taken over. The client states that he will not pay any claims fee, which means you mustn't draft more than 15 claims, and he says he will not pay any fees for further patent applications, so you must get everything into a single patent application and not propose 2 or more patent applications to cover this particular invention. So that is the end of the client's letter. We still have to read the prior art documents, beginning with document D1. Here we have document D1. I'm just trying to find where I've laid my document D1. Here we have D1, yes. We have the drawing of figure 1 of D1 is shown on this slide. What we're going to do is we'll read through the D1 document paragraph by paragraph, making comments on each paragraph, and you should make your notes as you go along, as you read the document. Paragraph 1 of D1 says, this article describes a nutcracker made of stainless steel. Figure 1 shows a perspective view of the nutcracker. It has 2 elongate levers 4 and 5 that are connected to each other by 3 connecting elements 1, 2 and 3. The connecting elements 1 and 2 are straight. The connecting element 3 is arranged between the connecting elements 1 and 2 and is curved. The lever 4 is pivotally attached at one of its ends to each of the connecting elements 1, 2 and 3 by means of a pin 6. The lever 5 is pivotally attached at one of its ends to each of the connecting elements 1, 2 and 3 by means of a pin 7. The pins 6 and 7 constrain the movement of the connecting elements 1, 2 and 3 so that they cannot move relative to each other. The levers 4 and 5 and the connecting elements 1, 2, and 3 define a space for receiving a walnut. The sides of levers 4 and 5 facing each other have ridges to prevent the walnut from slipping. Good. So what I've noted there is a nutcracker of stainless steel, levers connected by straight and curved connecting elements, pivotally attached at one end by pins. The connecting elements cannot move relative to one another. There is a space for receiving a walnut, and the sides of the levers have ridges. All of those features I have underlined on the text. Then I go to paragraph 3. Paragraph 2 is an introduction to the figures. Paragraph 3 says the walnut is placed between the levers 4 and 5 and the connecting elements 1 and 2, figure 2. You should have figure 2 available. The lever 5 is then pushed towards the lever 4 so that it rotates about the pin 7, figure 3, arrow A. The space is thereby restricted until the lever comes into contact with the walnut. If the lever is pushed further, the shortest distance between the levers 4 and 5 decreases further, so that the space is further restricted and the walnut is cracked by the levers 4 and 5 and the connecting elements 1, 2, and 3. And it says figure 4. So we already saw the operation by looking at the drawings, and I've noted down walnut placed in space, levers pivoted to restrict space, walnut cracked by pivoting levers further. Those were the features which I underlined. And then we go to paragraph 4. The client says the length of the connecting elements 1, 2, and 3 is shown in the figures, as shown in the figures, is chosen for cracking walnuts. For cracking smaller nuts, such as hazelnuts, a nutcracker having shorter connecting elements would be better. So I've noted down shorter connecting elements are better for cracking hazelnuts. In brackets, nutcracker has to be modified. And then that's the end of the D1 description. And I've noted down from the client's paragraph 23, where he discussed D1, that D1 uses a lever effect like the client's invention. So that feature was imported from the client's description. Next, we turn to prior art document D2. Do you have D2 handy? We need the D2 description. Figure 1 of D2 is shown on the slide. We're going to read through the paragraphs of D2 and make some notes as we go along. Starting with paragraph 1, this article describes a nutcracker. Figure 1 shows a perspective view of the nutcracker. Figs 2 to 4 show side views of the nutcracker. The nutcracker comprises 2 blocks, 1, 2, and 4 parallel cylindrical rods, 3, 4, 5, and 6. Each block 1 and 2 has 4 circular through holes. The rods 3 to 6 are mounted in the through holes. The diameter of the rods 3 to 6 is slightly smaller than the diameter of the through holes, so that the rods can rotate in the through holes without the blocks 1 and 2 moving, and the blocks can slide along the rods without the rods moving. So that was paragraph 1, and all I noted was nutcracker comprises blocks slidably mounted on parallel rods, as we have seen by looking at the drawings. We go to paragraph 2 of D2. The rods 4 and 5 are connected to each other at their respective ends by rigid strips 7 and 10. The rods 3 and 6 are connected to each other at their respective ends by rigid strips 8 and 11. The strips 7, 8, 10 and 11 ensure that the rods 3 to 6 are permanently attached to the blocks 1 and 2. A ring 8 is fixed to the strip 8, a ring 12 is fixed to the strip 10, that's paragraph 2. So all I've noted down is the rod ends are connected by rigid strips with fixed rings, or rings fixed. And we turn to paragraph 3, which is referring to the operative figures 2, 3 and 4. Let's see, paragraph 3. To crack a walnut, the walnut is placed in the space between the blocks 1, 2 and the rods 3 to 6, figure 2. The rings 9 and 12 are then abruptly pulled apart, arrows A and B, so that the strip 11 pushes the block in the direction of arrow A, and the strip 7 pushes the block 2 in the direction of arrow B. The block 1 slides along the rods 4 and 5 in the direction of arrow A, and the block 2 slides along the rods 3 and 6 in the direction of arrow B. The space is thereby restricted until the blocks 1 and 2 come into contact with the walnut, figure 3. The blocks 1 and 2 move further so that the space is further restricted and the walnut is cracked by the blocks, figure 4. So that's all very complicated, but we understood it by looking at the drawings, and I've noted down walnut crack by pulling rings to bring blocks together to restrict space. We turn over the page of the document D2 description to paragraph 4. After cracking the walnut, the blocks 1 and 2 are pulled apart. The block 1 slides along the rods 4 and 5 in the direction of arrow B, and the block 2 slides along the rods 3 and 6 in the direction of arrow A. This causes the rods 3 and 6 to move in the opposite direction to the rods 4 and 5. The space is enlarged until the nutcracker is again in the position shown in figure 2. In this position, the cracked walnut can be removed from the nutcracker, and I have noted down for paragraph 2, cracked walnut are removed by moving blocks apart, for all that description. And then we have a final paragraph, which is paragraph 5, which says, although the figures show the nutcracker cracking a walnut, it can also be used to crack a smaller nut, such as a hazelnut. And I've noted down D2 can be used to crack walnuts and hazelnuts. And I've noted down on the slide from the client's paragraph 23, with D2, skill is needed to crack nuts without crushing them. Now I'll make a short summary of purposeful reading. Firstly, you may have noticed there is a massive amount of information in a few pages with plenty of details, and it's easy to get distracted with a lot of details. We have found some guidance for essential features for claim 1. Just to give an example, there should be at least 3 rods. There is plenty of information given about optional features and variants, which we will be able to use when we are drafting our dependent claims. We have also some useful information about the prior art and about the relationship of the client's invention to the prior art that we will be able to use when we are arguing for novelty or inventive step over the prior art. And all of this information, massive amount of information, needs to be organized, and the organization of this information is the next task which is part 2 of this tutorial. So what then is next? In drafting part 2, we will organize the information in accordance with the predetermined output. In other words, the output is going to be a main independent claim, set of dependent claims, and an introduction to the description according to Rule 42. And we'll do this organization with a view to bringing the information together so that it will be in place for writing up our final product. This brings drafting part 1 to an end. Assimilation of information. Please continue with drafting EQE paper 2 part 2, organization and planning. So I invite you to open up the YouTube video on part 2 to continue the exercise. And so I will say a bientôt.